Welcome to Peptide-Proof, your source for rigorous, independent, evidence-based peptide intelligence. Your skin has a collagen switch. Can this peptide turn it back on? Today's explainer breaks down the biological mechanisms, the delivery science, and the formulation reality of Palmitoyl Tripeptide-5. Commercially, you probably know this as Syn-Coll. It's a highly specific, synthetic 3-amino acid chain that was actually designed in Switzerland, and its entire biological purpose? To infiltrate your skin and autonomously rebuild the dermal scaffold. We're going to look at exactly how it pulls that off, and importantly, where the honest limits sit. To understand the solution, we've got to look at the biological baseline first. Right around our late 20s, our natural fibroblast factories just start to slow down. They drop collagen production by about 1% every single year. And at the exact same time, you have these enzymes called MMPs stepping in like a demolition crew, relentlessly breaking down your old collagen. So, when your body is building less but destroying the exact same amount, you get this persistent deficit. The scaffold thins out, the skin loses that youthful bounce, and those visible wrinkles start to show up.
Now, this brings us to our hero ingredient, but there's a really crucial distinction we need to make right off the bat. Syn-Coll is not collagen itself. Instead, it uses a precise lysine-valine-lysine chemical sequence to act as a signal peptide, or what we call a matrikine. So it's not physically adding new collagen into your skin. It actually acts more like a biological formant. It infiltrates the tissue, walks right up to your existing fibroblasts, and commands them to wake up and start manufacturing new matrix proteins.
Okay, let's look at the biological pathway to see how this actually builds. Syn-Coll is cleverly engineered to mimic the KRFK active region of a native protein called thrombospondin 1. By imitating this highly specific region, Syn-Coll basically acts like a master key. It unlocks dormant TGF-beta complexes that are already just sitting there in your skin. Once freed, that active TGF-beta binds directly to fibroblast receptors, tags two specific proteins, SMAD2 and SMAD3, and sends them straight into the cell nucleus. The result of all that signaling? It turns up your COL1A1 and COL1A2 collagen genes, which leads to a gradual, structural thickening of the dermal scaffold.
But here's the thing, a cellular message is completely useless if it can't cross the skin barrier. According to the 500 Dalton rule, bare, water-loving peptides usually just bounce right off the skin's fatty outer layer. So to solve this physics problem, the peptide undergoes lipidation. Formulators attach a 16-carbon palmitoyl fatty acid tail to that tiny 3-amino acid chain. This bit of engineering gives it a massive functional advantage. It makes Syn-Coll fat-soluble. So now, it can easily penetrate that lipid barrier and linger right near the cell membrane, exactly where those target receptors live.
Beyond the headlines.
Into the research. Peptide-Proof.
So, what does the clinical proof actually look like? Well, in vivo testing on 45 volunteers used 3D profilometry. That's a device that literally traces every tiny ridge and valley of the skin surface. What they found was that a 2.5% dose yielded a 12% reduction in wrinkle depth over an 84-day window. Even a 1% dose yielded a 7% improvement. So it is a real, measurable structural change. But we do need a quick clinical reality check here. Because Syn-Coll relies on nudging your own TGF-beta system, the results rely heavily on the baseline health of your existing fibroblasts. Younger, more responsive cells are just naturally going to yield greater benefits.
Now, simply seeing Syn-Coll on an ingredient label definitely does not guarantee biological results. Execution dictates performance, and there's some strict formulation rules you really need to look out for. First up is the dose. The peptide must sit in the top third of the ingredient list to actually hit that 1 to 2.5% efficacy window. If it's way down at the bottom, it's just decorative. Second is the 84-day rule. Collagen synthesis is inherently slow, so it demands a minimum of 12 weeks of consistent application. And third is the pH conflict. Peptides are highly delicate. Syn-Coll needs a stable environment totally isolated from strong, degrading acids like low pH vitamin C. Those acids can literally chew up the peptide before it ever has a chance to reach the dermis.
Because Syn-Coll operates slowly on that upstream TGF-beta switch, smart formulators are going to stack it strategically. The goal here is to combine complementary pathways, not redundant ones. For example, Syn-Coll pairs exceptionally well with a downstream collagen fragment like matrix cell. That gives the skin a much broader structural push. Alternatively, you could pair it with a fast-acting neurotransmitter inhibitor like argireline. By pairing a slow-building collagen signal with a fast-acting muscle relaxer, you're addressing completely different aging mechanisms at the exact same time.
All right, to distill all of this down for you, here's your complete Syn-Coll intelligence brief. The mechanism relies on KRFK mimicry to unlock dormant TGF-beta and command those fibroblasts to initiate collagen production. Delivery is completely dependent on lipidation, that 16-carbon palmitoyl tail, to bypass the skin's natural barrier. The clinical evidence points to a measurable 12% reduction in wrinkle depth at a 2.5% concentration over 84 days. And finally, real-world application absolutely demands strict patient adherence, proper concentration in the top third of the formula, and a pH-stable environment.
That's all for this explainer. Comment peptide, and I'll send you the latest peptide skincare research and ingredient insights. Thanks for watching, and we'll see you next time.